The calculations in a chi-square goodness of fit test allow us to measure how far away the observed sample data are from what we expected to see if the proposed percentages were true, and we reject the null if the observed data are too far away from what was expected. We demonstrate the calculations with an example. Suppose the proposed distribution says that 40% of new iPhones purchased are gray, 35% are silver, and 25% are gold, and that for a sample of 100 phones, we observed 30 gray, 48 silver, and 22 gold. First, we calculate what we expect the data to look like if the proposed percentages were true by multiplying the total sample size n by each percentage. In our example, 100 times each percentage gives us expected frequencies of 40 gray, 35 silver, and 25 gold. Next, we measure how far away each observed count is from each expected count by subtracting the two. This is called the error. In our example, for gray phones, we would take 30 observed minus 40 expected, and that equals minus 10. To make sure the positive and negative differences don't cancel each other out, we square the difference. In our example, minus 10 squared equals 100. Next, we divide the squared error by the expected count to find the relative squared error, called RSE, for this category. In our example, we would take minus 10 squared divided by 40, which is 100 divided by 40, or 2.5. We do this because a difference of minus 10 is relatively small if the expected value is, say, 1,000, but is relatively large if the expected is, say, 5. We repeat this process for each category to get a relative square error for each. The RSEs are 4.83 for silver and 0.36 for gold. Now, to find the overall distance between all observed and expected counts, we sum the relative square error to get the total relative square error. In our example, the total RSE is 2.5 plus 4.83 plus 0.36, which is 7.69. Lastly, to determine if this overall distance is large or small, statistically speaking, we note that the total RSE follows a chi-square distribution with k minus 1 degrees of freedom, where k is the number of categories. Using this distribution, we can calculate either a critical value or a p-value and determine whether or not there is evidence to reject the null. In our example, there were k equals 3 categories, so we have 2 degrees of freedom. Using a chi-square table or online calculator, the right-tail critical value for 2 degrees of freedom using a 5% significance level is 5.991. So in this case, we would reject the null that says the data follows the proposed distribution because our measure of distance, 7.69, is greater than 5.991. Alternatively, you could use statistical software or a chi-squared calculator to compute the p-value of this test, which is the probability that a chi-square with 2 degrees of freedom is larger than our test statistic 7.69. This would yield a p-value of 0.0214. Once again, we would reject the null because the p-value is less than the level of significance.
Created using Powtoon.